Alright everyone, welcome to Algebra 2, Section 6.3, Solving by Factoring Polynomials. So we're supposed to find the zeros by factoring completely for this warm-up. This is a review back from what we did in a previous chapter when we talked in depth about quadratics. First step is to make sure it is equal to 0. It is. Now we take a GCF out if there is one, and there is a GCF of 3. So we're left with 2x squared minus 5x minus 3 equals 0. Now since there's 3 terms, we make an x. Top of the x, we have 2 times negative 3, which results in negative 6. Bottom's negative 5. 2 terms that finish the x are negative 6, positive 1. And since a is 2 and not 1, we cannot do the shortcut. So we rewrite it 2x squared minus 6x plus x minus 3. And we put that 3 out in front, and it's equal to 0 still. Now we group the first 2 terms, the last 2 terms, taking the sign with the third term. Now we say first 2 terms, they have a 2x in common. We're left with x minus 3. Second ones just have a 1 in common, so we're left with x minus 3. And don't forget the 3 out in front as a GCF, and it's all equal to 0 still. Now we say, hey, those are the same parentheses, that's good. Put that in front. Then the other leftovers are 2x plus 1 equal to 0, and we can't forget that 3 out in front. Now as we start to solve, we would say, hey, 3 equals 0, but it can't. X minus 3 equals 0, and 2x plus 1 equals 0. So now, as we solve these equations, we add 3 to get x equals 3, and we subtract 1 and then divide by 2 to get negative 1/2. And you can always check those by plugging them back into the original equation and validating or verifying, that they equal 0, which they would. Alright, so we're going to continue solving equations by factoring. And it says, hey, make sure it's set equal to 0 and solve. So here, 4 terms, it's equal to 0. Look for a GCF, there is none. Group the first 2, group the last 2 when there's 4 terms. So just like we did during warm-up when we made 4 terms by grouping the first 2, last 2, we're going to go ahead and group the first 2 and last 2 when it starts with 4 terms as well. And we talked about that last lesson in section 2. First parenthesis has m squared in common, and we're left with m plus 6. Second parenthesis has a negative 4 in common because we want it to start positive and not negative. And we're left with m plus 6. Those are the same like they should be. So we put m plus 6 in front. And m squared minus 4 next. That second one's not done yet. It's a difference of 2 squares. So we do m plus 6. And the second one becomes m minus 2 and m plus 2. And that's all equal to 0. So now we set each of those equal to 0. M plus 6 equals 0. M minus 2 equals 0. And m plus 2 equals 0. And by solving these, we get m equals negative 6, as well as both positive and negative 2. And remember, there's multiple ways you could write this, as long as those are your 3 numbers. Example B, we have it equal to 0, and we have a GCF, so we're going to start by taking that out. And our GCF is 3a to the third, and we're left with a squared minus 25 equals 0. Well, inside there's 2 terms, so we look for a difference of 2 squares, and it is a difference of 2 squares. So our 2 parentheses are going to be a minus 5 and a plus 5. That still equals 0. Set each of these equal to 0. Solve each of them. And this one results as after you divide it by 3, as in a cubed equals 0. But we can remember that, hey, oh, my Apple Pencil's almost dying. We can remember that the only thing to the third power that would be 0, aka something times itself 3 times that equals 0, would be 0. And our other two result in positive and negative 5. So if we plug in 0, positive, or negative 5, we get our answer. And the reason there's only 3 numbers this time rather than 5, even though the biggest exponent was 5, is because 3 of the answers are all 0. And no, you don't have to write 0 3 different times. Letter C. Might be a good idea to try this one on your own. You'll end up with a square root answer though. So this has a GCF and it is equal to 0. GCF is 4w cubed, and we're left with w squared minus 16 equals 0. So we not 16, let me try that again. Minus 21 equals 0. So now we cannot factor this any further. It's 2 terms, and 21 is not a perfect square. So we set it equal to 0. 4w cubed equals 0. W squared minus 21 equals 0. The first one we solve the same way we did earlier, where we divide by 4 and we say, hey, wait a second, w cubed equals 0. The answer has to be 0 because nothing else times itself 3 times would be 0. And then for our other answer, we say, okay, however we want to solve this quadratic, I would recommend adding 21 and getting w squared equals 21. Now we need to square root both sides, and you get w. And when you square root both sides of an equation, remember, you create the positive and negative scenarios. And it is the square root of 21, which does not reduce. And so those are our 3 answers. And once again, even though I'll clarify 3 answers because positive and negative are 2 answers total. And even though there's a highest exponent of 5, there's only 3 numbers because w to the third ended up equaling 0, so 0 is 3 of the answers. Alright, I recommend going and trying D on your own. For D, it's equal to 0, and there is a GCF. So we take an x out, and then we are left with 2x squared plus 7x plus 5 equals 0. 3 terms in the middle, so we take the x, or making x. We have 2 times 5, so 10 on top, 7 on the bottom. 5 and 2 do the trick. A is 2 and not 1, so no shortcut for this either. So we put 2x squared plus 5x plus 2x plus 5. And a reminder that the 5x and 2x are interchangeable. And we have the x out in front. Next step is to group the first 2 and the last 2. And we say, okay, well, the first 2 have an x in common, and we're left with 2x plus 5. Last 2 just have a 1 in common, so we're left with 2x plus 5. And there's an x in front of all of it. Now we say those are the same parenthesis, that's good. Put that in front. Leftovers make x plus 1 as the other parenthesis. And the x out in front. And it equals 0. None of these can be factored further, so we set each equal to 0. X equals 0. 2x plus 5 equals 0. And x plus 1 equals 0. Solving each of these results in, negative 5 over 2, negative 1, and 0. Letter E. You notice that letter E doesn't equal 0 this time, so we have to make it equal 0 by adding 36 to both sides. And 36 doesn't combine with any of these because it does not have a variable, while the others do. So we get 5x cubed plus 15x squared plus 12x plus 36 equals 0. Now it equals 0, and there's no GCF, so we continue factoring. And we say, hey, there's 4 terms this time. So group the first 2, group the last 2. First 2 have a 5w squared in common, 5x squared in common. I accidentally wrote w for one of those terms. Let me fix that. So first have a 5x squared in common, and we're left with x plus 3. Last 2 have a 12 in common, a positive 12, and we're left with x plus 3. Hey, those are the same. That's good. So we put that out in front, and we're left with 5x squared plus 12 equals 0. Now, as we go to solve the first one, we say x plus 3 equals 0, or excuse me, and solve the other one, 5x squared plus 12 equals 0. The first one, we subtract 3 and get x equals negative 3. The other one, it's not quite as easy. We subtract 12 and get 5x squared equals negative 12. Then we divide by 5, and we end up getting x squared equals negative 12 over 5. So as we go to square root both sides, we have to take x equals the positive and negative square root of negative 12 over 5, which, yes, we can simplify, and we do know how, although we might not remember currently. But first of all, wait a second, a negative number, that's an imaginary number. And in this unit, it's good enough to say, hey, you know what, that's one of my answers, and we're going to call that imaginary. Sometimes you'll be allowed to do that, and sometimes you'll have to take it further. If you were to take it further, you would end up getting this answer to end up being x equals positive or negative 2i times the square root. Oh, excuse me, before I continue, I messed up. The square root should be over the entire thing, or on the top and the bottom individually. This would end up being positive or negative 2i times the square root of 15 over 5. Once again, it's good enough to leave it like that in this unit and say, hey, that's imaginary. All right, letter F. Recommend trying this one on your own. So it doesn't equal 0. So move these two terms over, and they both need to be subtracted in this case. And as we subtract them, we notice there's no like terms on the left side. So we do x cubed plus 6x squared minus 3x minus 18, and it equals 0. Group the first two, group the last two, since it's 4 terms and there's no GCF. First two have x squared in common, and we're left with x plus 6. Second two have a negative 3 in common, and we're left with x plus 6. Those are the same, so we put that in front. The leftovers is x squared minus 3. The second one cannot be factored any further because 3 is not a perfect square. So we set h equal to 0 and solve. The first one results in x equals negative 6. The second one, we have to add 3 to both sides, and we get x squared equals 3. Then as we go to square root both sides, undo the square, we get x equals positive or negative square root of 3, which can't be simplified any further. So those are our 3 answers. Once again, the positive and negative, 2 answers total. All right, last but not least, a real-world example. So, in 1980, archaeologists at the ruins of Caesarea discovered a huge hydraulic concrete block with a volume of 330 cubic yards. The block's dimensions are x yards high by 13x minus 11 yards long and 13x minus 15 yards wide. What's the height? Well, good rule of thumb is always to underline or highlight, somehow pull out key information. Key information is that, hey, it has a volume of 330 cubic yards, and the dimensions are x yards high, 13x by 11 yards long, and 13x by 15 yards wide, 13x minus 15 yards wide, and that we want to know the height. Well, if you don't know, the volume formula is volume is equal to length times width times height. That's very important to know here, because we know the volume to be 330 cubic yards. We know the length to be x yards. So the length is 13x minus 11 yards, because it says 13x minus 11 yards long. We know the width to be 13x minus 15 yards, and we know the height to be x yards. Now, we need to plug these in and solve. So plugging them in would look like this. 330, the volume, is equal to length times width times length times width times height in any order. So I'm going to actually put the x first. X, and then 13x minus 11, and 13x minus 15. Once again, you could put those three parentheses in any order. Now, before we subtract 330, because we said, let me back up. So this is our equation. Now, in order to solve this, we'll need to end up equaling 0, and then we'll need a factor. You might say, well, Mr. Coswell, it's already factored. And while it's true, it's factored but equals a non-zero number. So we're not able to do anything. So we're actually going to have to work backwards by multiplying these all together, then move the 330 over, and then finally we'll be able to actually factor the new problem. So I'm going to leave the 330 there for the time being and distribute the x to the first parenthesis. And we get 13x squared minus 11x. And that second parenthesis just stays the same, just chilling there. Now, we multiply the two parentheses together by FOILing. So we get 13x squared times 13x is 169x cubed. 13x squared times negative 15 is negative 195x squared. Negative 11x times 13x is negative 143x. And negative 11x times negative 15 is positive 165x. And that it already equaled to 330 on the other side. Oops, I misspoke. The negative 143x is an x squared. Now we're going to combine like terms, and we're going to get 169x cubed, and those middle two terms on the right hand side can combine to end up being negative 338 x squared minus plus 65x. Now we need to subtract 330 from both sides, and I'm going to have the equal 0 on the right hand side rather than the left, but either way is fine. So after the 169, I transposed some numbers and inserted a new one somehow. 169x cubed minus 338x squared plus 65x minus 330 equals 0. Now it is equal to 0, and we got four terms. So we look for a GCF, which there is none. So now we look to factor by grouping, which is grouping the first two and the last two. But before we move fully into that, let's first talk about the work we've done so far. So in our first step, we said, okay, hey, wait, here, let's plug everything in, and now it's factored but equals a non-zero number. So we need to make sure it's factored and equals 0 in the end of the day. So we have to first unfactor it by distributing. So we distributed, and then we distributed again. Then we combine like terms from blue to orange, and from orange to green. We move that 330 over from one side to the other by subtracting it, and set it equal to 0. Now we're able to proceed and make it factoring that equals 0. So we go the first two, last two. The first two have 169x squared in common, and we're left with x minus 2. The last two have 65 in common, and we're left with x minus 2. Excuse me. I miswrote that multiple times. Way back at the beginning. It's never been plus 65x, it's been plus, and you probably noticed this a while ago, and I apologize for that, 165x. So they don't have a 65x in common. They have 165 in common. And now we're left with x minus 2. I apologize once again for that. So x minus 2 and x minus 2, those are the same. And our other parenthesis is going to be 169x squared plus 165. And now we have two factors that equal 0. The second one cannot be further factored. So we set h equal to 0. As we begin to solve, we solve the left-hand one by adding 2 and get x equals 2. We solve the right-hand one by subtracting 165. So we get 169x squared equals negative 165. Well, you might already notice something going on, but if you don't, we can continue on. We divide by 169, and you'd get x squared is equal to negative 165 over 169. And you might also notice the same thing I was talking about a moment ago now. But if you don't as well, that's okay. You square root both sides. Now we'd want to notice that, hey, when you squared a negative number, that creates an imaginary solution. Now we have to ask ourselves, if we are solving a word problem, real life, are there imaginary numbers in real life? Well, the answer is no. And specifically with this, when we're talking about the dimensions of an object, can you have imaginary lengths? No, you can't. So it's okay for us to say, hey, that's imaginary, and stop there. And if you notice that it was imaginary a bit ago, like you might notice that as soon as you see this parenthesis, because you have an x squared plus a number. And it's a positive on front. If you have that scenario, it's going to be an imaginary every time, because you'll always have to subtract to give yourself an equal or negative. Dividing will not change the sign when you're dividing by a positive. And then you'll have to square root that. So anytime you're going to be square rooting a negative, you know it's going to be imaginary. So our only answer we're really concerned about is x equals 2. Now we can't just box it and call it good and say we're done for the day, because the question we're asked is, what is the height? So we say, okay, the height, we said it was x yards. So actually, we can say, hey, the height is 2 yards, and we're done. If you're asked to put it in a full sentence, you would say something along the lines of, the height of the block is 2 yards, or the block is 2 yards high, or something akin to that, or similar to that. All right, that is it for section 3, but real quick, I want to recap the problem on the end, that, hey, we took our information, and we said, hey, volume is equal to this length times width times height. If you don't know that, you can always Google it or just ask. Then we plugged in what we knew, saying volume, length, width, height, and we said, hey, we have factoring, but it's not equal to 0, so we multiplied it back out, set it equal to 0, then refactored, and then we're able to actually solve it. We said we don't need an imaginary answer when we're talking about height or length or width or real world scenarios in general. So we just said, hey, x equals 2, and plug that in, and got 2 yards as our height.